Today we're going to talk about integrating reciprocal functions. Let's get started with those properties. The integration reciprocal function is that we have the indefinite integral of 1 over x with respect to x. That result equals the natural log of the absolute value of x plus c. All right, this is the chain rule other method right here. 1 over u du equals the natural log of the absolute value of u plus c. Here we have example 1. We have the indefinite integral of negative 10 over x dx. Our instinct is going to tell us to factor out the negative 10 and then take the indefinite integral of x to the power of negative 1 dx. Right? This is our instinct. It's going to end up telling us do this and then use the power rule, right, which becomes x to the negative 1 plus 1 over negative 1 plus 1 plus our constant. All right, negative 1 plus 1 is 0, so our exponent to the power of 0 is not the big deal. That's 1. But the problem comes in right here with the denominator. We can never have a 0 in the denominator unless you're finding limits and then using L'Hopital's rules, and there's a different story. All right, so for this one, right, that's where our rules came in handy right here, right? The indefinite integral of 1 over x with respect to x equals the natural log of the absolute value of x. Another way of rewriting this is this right here, and that equals the natural log of the absolute value of x, again, plus c. Again, whether it's this format or this format right here, all right, both are equivalent to each other, and this here is the wrong way to do it. So the correct way to do it here would be, if you want to bring out that negative 10 over, that's fine, right? Others, more than likely you're not going to see it this way. More than likely you're going to end up seeing it this way right here, dx over x. Whether it's these two, they are both equivalent. From here, you can jump into the natural log of the absolute value of x plus c, and this here is your answer to that right there. All right, so here we have example number 2. All right, again, different way of rewriting this, right? We can factor out this negative 2, the indefinite integral of x to the power of negative 1 with respect to x. Again, I already have x to the power of negative 1, so this is going to become negative 2 times the natural log of the absolute value of x plus our constant. Nothing else to do. Easy as that for examples 1 and 2. Let's move on to something a bit more challenging. We have the indefinite integral of 80 times x to the 4th power. That's all over the binomial 4x squared, 4x to the 5th power minus 1 with respect to x. Again, this is very easy. All you have to do is just use substitution. Let u equals, in this case, our denominator, 5x to the 5th power minus 1. Du, when we take the derivative, is 20x to the 4th power dx. Again, I like solving for dx because we can just replace this dx with whatever down here. So dx equals du over 20x to the 4th power. All right, so now let's replace some stuff with for the original example. The indefinite integral of 80 x to the 4th power all over, this gets now replaced with u. Dx gets replaced with this here, so it's du over 20x to the 4th power. X to the 4th powers reduce each other to 1. 80 divided by 20 is 4. So now I have the indefinite integral of 4 over u with respect to u. All right, I can factor this out because it is a coefficient. So now I have 4 times the indefinite integral of 1 over u du. So now this actually becomes 4 times the natural log of the absolute value of u, since in this case u is our variable, plus our constant. All right, you're not going to see this answer in a multiple choice question because it's going to tell you leave your answer in terms of x. So I'm going to rewrite it with x back in there. 4x to the 5th power minus 1 plus our constant. And that is our solution. All right, something slightly different, nothing to worry about. The only thing that's different here is now we have a new variable. Let's not that intimidate you. All we have to do is just, again, use the substitution method. Let u equal 2y squared minus 1. So the derivative of u, du, is equal to 4y, not dx this time, but in this case is dy. We're going to replace dy, so solve for dy. So I'm going to have dy equals du over 4y. All right, so now this becomes 4y over, this gets replaced with u. This dy is now du over 4y. 4y and 4y reduce each other to 1 or divide to 1. So now I have the indefinite integral of du over u. So this becomes the natural log of the absolute value of u plus my constant. So now it is the natural log of 2x squared minus 1 plus our constant, and that's it. Last example. Again, looks very intimidating. All we have to do is just remember substitution for the denominator, because again we're dealing with reciprocals. So we're going to let u equal cotangent of negative 4x. So du is going to equal to the cosecant square of negative 4x times, this is where a lot of students are going to end up making a mistake. I need to use the chain rule. Negative 4 dx, and I just made a mistake here. All right, the derivative cotangent is negative cosecant squared of negative 4x times negative 4 is chain rule, and then dx with the implicit differentiation. All right, here I am going to solve for dx because I'm going to replace dx. So dx eventually is going to equal to du over 4 cosecant squared of negative 4x. All right, so now I'm replacing stuff. The indefinite integral of 20 times the cosecant square of negative 4x all over u. Dx is now this right here, which is du over 4 cosecant square of negative 4x. Cosecant square of negative 4x reduces each other out to 1. 20 divided by 4 is 5. So now I have 5 times the indefinite integral of du over u. Once everything's been simplified out, this is now 5 times the natural log of the absolute value of u plus c. Then put back everything in terms of x. 5 times the natural log of the absolute value of the cotangent of negative 4x plus c. And that there is our final answer. Intimidating, but again, if you use substitution, it should be straight out.